Using special triangles, just look at here. This vertical line will be looking. Vertical line will be see 90 degree here, 45 degree. See here in a 45 90 triangle sides are in the ratio 1 is to 1 equal 1 dash 1 dash root 2. This means I can build a triangle with those lengths for sides. Any multiple those lengths. This is the 1. This is root 2. We can then find the sixth triangular functions of 45 degree using the triangle. Sine 45 degree, cos 45 degree, tan 45 degree. 1 by root 2 by 2 rationalized. 1 by root 2 by 2, 1 by what is the radian equivalent of 45 degree? 5 by 4. You also know all the triangular function for 5 by 4, then secant theta 5 by 4, tan theta 5 by 4, reciprocal of COs 5 by 4 root 2 by 1 root 2 5 by 4 1 by 1. The 30 60 90 triangle 30 60 90 triangle sides are in the ratio 1 minus root 3 minus 2. This means I can build a triangle with those lengths for sides. This is the side of 30 degree, this side of 60 degree, side of 90 degree. This is 1 comma root 3 1 root 3 by 2 1 by 2 root 3 by 1. See here, this is 30 60 90 triangle. See here, what is 1 dash root 3? This is the root 3. You have know the trigonometric function sine, cos, tan, cot, cosec, sec, 0 degree, 30 degree, 45 degree, 90 degree. That values here will be indications. You can draw the triangle. So already I will be explaining the earlier videos in what are the values is there in sin theta, cos theta, tan theta, cot theta, cosecant theta, and secant theta. See here, sin 30 is equal to 1 by 2, cos 30 is equal to root 3 by 2, tan 30 is equal to 1 by root 3. Please look at here. What this means is that you have memorized the special triangle, then you can find all the trifunctions of 45 degree, 30 degree, and 60 degree, which common ones you need to know. You also can find the radian equivalents of those angles. See 45 degree 5 by 4, 30 degree 5 by 6, and 60 degree 5 by 3. See, when the directions say find the exact value, you must know those values not a decimal approximation that your calculator is given by gives you. Here is a table of sines and cosines for common angles. You can get those drawing the special triangle, but notice the pattern. Sine 0 degree 0 by 2 equals to 0, sin 30 root 1 by 2, 1 by 2, sin 45 root 2 by 2 equals root 2 by 2, sin 60 root 3 by 2 equals root 3 by 2, sin 90 root 4 by 2 equals to 1. Same you have in a opposite, you have in a sin, you have in a cos. Cos 0 is equal to root 4 by 2 equals to 1. Cos 30 is equal to root 3 by 2, root 3 by 2. Cos 45 root 2 by 2 equal to root 2 by 2. Cos 60 is equal to root 1 by 2, 1 by 2. Cos 90 is equal to root 0 by 2. Using a calculator to find the values for trigonometric functions, if we wanted to sin 38, we could not use the previous method to find it because we don't know the length of sides of a triangle with a 30-degree angle. We will then use our calculator to approximate the value. You can simply use the sign button on the calculator followed by 38. See here, sin 38. Just you go to, this is the scientific calculator to allow the examination also in scientific calculator, but you have in the competitive exams in KE is not allowed any scientific calculator. Be careful that when you bringing the calculator, you have a must and should, you know the values. You are not allowed to the KE in calculation in the government exams. You can simply use the sign button on calculator followed by 30 degree to find the sin 38. A word to a word to the wise. A word to the wise. Always make sure your calculator is the right mode for the type of angle you have. If there is not a degree symbol, then you know the angle is in radians. Using calculator to find the values reciprocal triangular functions. If you wanted 5 by 5, 5 by 5, we use our calculator to approximate the value, remembering that cosecant is the reciprocal function of sine, so it's 1 over sine. You can simply put in 1 divided by sine followed by 5 by 5 to find the cosec 5 by 5. Make sure you are in the radian mode and that you put the 5 by 5 in parentheses. See, this is the scientific calculator. This scientific calculator you have in a sine function, and you put shift and then put sine inverse is there. Same thing in cos is there. You put shift and you have a cos inverse. Then tan is there. You have a shift tan inverse is there. This is sine, cos, and tan values is there here. Once you put the button, then it will be opposite values is there. And this is the 1, 2, 3, 4, 5, 6, 7, 8, 9. All the values is there. This scientific calculator to allow the examination are the fundamental identity and reference angles. See, I'll be move for the next chapter or next units. The fundamental identity and the reference angles. The fundamental identity A, B, C, A square plus B square equal to C square. Now to discover my favorite identity, let's start with the right triangle and fall Pythagorean theorem, Pythagorean theorem. You know in what is meaning by Pythagorean theorem? Just I write it here. See here, this is the A value, this is B value. A square plus B square equal to C square. C is equal to square root of A square plus B square. This is the Pythagorean theorem. Pythagorean theorem. Just I written here, what is written here in the Pythagorean theorem, C is equal to square root of A square plus B square. That is the Pythagorean theorem. See, rewrite the trending terms place divided by the term C square. Move the expansion B by C whole square plus A by C whole square equals to 1. Look at the triangle and the angle theta, determine which trifunctions. See B, this is C theta. This is sine, this is cos. See, this one is sine, this one is cos. Sine square theta plus cos square theta equals to 1. See, that is the final formula, sine square theta equals to plus cos square theta equals to 1. There is a method for finding the other 5 triangular function of actuate angle when you know the one function. This method is to use the fundamental identity. Sin theta is equal to 1 by 3, cos theta is equal to 3. Sin square theta plus cos square theta equals to 1. 1 by 3 whole square plus cos square theta equals to 1. Cos square theta is equal to 8 by 9. Cos theta is equal to square root of 8 by square root of 9. 2 into square root of 2 by 3. Let's list what we have so far. Cos theta is equal to 3. Cos theta is equal to 2 into square root of 2 by 3. Sin theta is equal to 1 by 3. Secant theta is equal to 3 by root 2. we need to get the tangent. Tan theta is equal to sin theta by cos theta. Tan theta is equal to 1 by 3, 2 into square root of 3. Simplifying involving, see, trigonometric functions of general angles. Our method of using right triangle only works for the acute angles. Now we will be see how we can find the trifunctions values of any angles. To do this, we will place angle on a rectangular coordinate system with the initial side positive in x-axis. See here, this is the reference angle theta dash. Theta, if theta is 135 degrees, see here 0 to 135 degree, we can find the angle formed by the negative axis, negative x-axis, and the terminal side of the angle. This is an acute angle, is called the reference angle, is denoted by theta. Theta is equal to 135 degree. What is measure of this reference angle? Since it is 360 degree all the y around a circle or around a straight line, 180 minus 135 is equal to 45 degree. Let's label the sides of triangular according to the 45, 45, 90 triangle. The sides might be multiple of those length, but looking as a ratio, this is the quadrant second angle. When you label the sides of, you include any sign. This is x and y. See here, this is a quadrant in second angle. This is the quadrant in second angle. When you label the sides, if you include any sign of them, thinking of x and y in that quadrant, it will keep the sign straight on the trigonometric functions. X values are negative in quadrant. Second, so put a negative. The values of the trifunctions of angles, their reference angles are the same, except possibly they may differ by a negative sign. Putting the negative and the one will take care of the problems. See, sin 135 degree, 0 by h, 1 by root 2 by 2. See, cos 135, a by h minus 1 by root 2 minus root 2 by 2. See here, notice the minus 1 instead of 1, since the terminal side of the angle is quadrant 2, where x values are negative. Tan 135 is equal to 0 by a, 1 by minus 1 by 1. We are going to use this method to find the angles that are non-acute. Finding an acute reference angle, making a triangle and seeing the which quadrant we have help with the sign. Let's now we go for the next slides. Let theta denotes the non-acute angle that lies in a quadrant. The acute angle formed by the terminal side of theta, either the positive x-axis or the negative x-axis, is called the reference angle theta dash and theta. Let's use this idea to find the sixth triangular function for 210 degree. See here. First draw the picture and label the theta. We know that 210 degree will be quadrant third. Now draw the perpendicular line from the terminal side angle to the axis in x-axis. The reference angle will be the angle formed by the terminal side of the angle and x-axis, and the reference angle is amount past 180 degree. Label side of the 30, 60, 90 triangle and include any negative sign depending on if x and y values are negative in the quadrant. See here, this is the 30 degree angle, minus root 3 minus 1 2. You will never put the negative on the hypotenuse sides of the triangle are not negative, but put the negative sign there to get the sign correction on the triangular function. You should thinking the is the reciprocal of sine and sine opposite over the hypotenuse. So hypotenuse over the opposite. Tan 210 minus 1 by minus root 3 minus root 3 by 3 and cos 210. See here, using the same triangle idea, we are given a point on the terminal side on angle. We can figure out 6 trifunctions of the angle by drawing a triangle. Given that point pi comma minus 12 is the terminal side of an angle theta, find the exact value of each of the 6 trifunctions. First draw the picture. See, now draw perpendicular line, the terminal side, then x-axis. Label the side axis, label the side of the triangle including any negative. You know the two legs because of there are the x and y values of the point. Use the Pythagorean theorem hypothesis. See here, 5 square plus minus 12 square is equal to h is equal to square root of 5 square minus 12 square. See, given that the point 5 comma minus 12 is on the terminal side of an angle theta, find the exact value of each of 6 triangular functions. We will call the reference angle theta as the trifunctions of theta are the same of theta exact the possibility of negative sign. Labeling the sides of triangle with negative takes this problem. Sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. In quadrant, both the x and y values the positive, so all the triangular function will be positive. All the triangular function are positive. Let's look at the sine of sine, cosine and tangent in the other quadrants. Reciprocal functions, we have the same sign of the as the original signs. Flipping a function over does not change its sign. See, in quadrant second, x is negative, y is positive. We can see from this that any value that required the adjacent side will then you have a negative sign on it. See, in quadrant third, x is negative, y is negative. Hypotenuse is always positive, so if we have either adjacent or opposite with the hypotenuse, we will get the negative. If we have both the opposite and adjacent, the negative will cancel. See here in quadrant fourth and x is positive and y is negative. So the functions using in opposite side, opposite will negative. Sine is negative, cos is positive, tan is negative. See, this is very, very important. All the triangular functions are positive, sine, cos, and tan. Here, sine only positive. Due to region of the vertical line will be positive. Cos and tan is negative. And third quadrant, tan is positive, sine and cos is negative. And fourth is cos is positive, sine and tan is negative. To help remember those signs, we look at what triangular functions are positive in each quadrant. See, all triangular functions are positive. Sine is positive, tan is positive, and cos is positive. Here is a see. Here is a. If you remember, all is positive. Students take. Just you have keep it in your mind. All students take the classes. Just you have in memorizing in your memory. All the students take the classes. All the students take the classes means all students take the classes. What about the quadrantal triangle? We can take a point on the terminal side, quadrantal angles, and use the x and y values as adjacent and opposite. Respectively, we use the x and y value that is not 0 as the hypotenuse use as well. See, try this 90 degree. See 90 degree, sin 90 degree 0 by h 1 by 1, cos 90 degree a by h 0 by 1, tan 90 degree 0 by A, 90 degree. Dividing by 0 is undefined, so the tangent of 90 degree, t degree. See, let's find the triangular function phi. Sin phi 0 by h 0 by 1 is equal to 0. Cos pi a by h equals to 1 minus 1 minus 1. Tan phi 0 by a 0 by 1. Phi 1 by 0 1 by 1 minus 1. Cot. A table your book lists the triangular values of the quadrantal angles. You will need to know them, but you don't need the memorize the table, learn how to draw the picture like we did find them. Let's finding the couple of reference angle radians. See here, this is theta 3 by 5, 3 into 5 by 4. What is measure of this reference angle? Since it is a 2 phi all the way around a circle, halfway around straight line is 5. 5 minus 3 pi by 4, 5 by 4. Find the reference angle 7 pi by 6. 7 pi by 6. First draw a picture and label the theta. We know that will be quadrantal third. The reference angle will be the angle formed by the terminal side of the angle. Then x-axis. Can you figure out its measure? The reference angle is the amount post 7 5 by 6 minus 5 5 by 6.